Hi data people, welcome back to my channel for tech career data and machine learning. And so in today's video, I'm going to cover, how do we use Python for data science, for like the filters and like creating new columns, and let's get started. So in Excel, it's quite easy to do your filters. You just have to simply select a column and then you can put your logic in like equals to 7. In Python, you can do exactly the same thing by typing df bracket df dot customer ID. So you're calling customer ID within the data frames or slash the data sets that you're calling and within the data frame. So make sure that you definitely have to type your data frame name twice. And also the equal sign has to be double equal sign to 7. And if you simply do that without, making like calling it something else like customer 7, then it wouldn't store as a different data set or data frame. So if you want to create like a subset of your data frame, then you definitely need to rename it to something else so it's stored as another data frame, that it's not just simply like showing you the results at the end. You know how you can choose different logical filters like greater than a certain number, contain certain things, or different ways of doing this. And in Python, you can do exactly the same thing by doing df bracket, same thing, your customer ID greater than 65. Without and making sure that if you're just trying to display the results, then yes, this will be fine. But if you want to store it as a subset of your data frame that you are working on, then definitely need to name it something else. So after we have covered the simple filter, now we're going to cover what do you do when you have filters with multiple conditions with the and or. So and meaning both conditions have to be met, and or meaning at least one of the condition has to be met. I have a sample data set on the right hand side, and I'm gonna talk about how would the same statement or same script, but just simply changing the and or would make a huge difference depending on which rows we're selecting. So first, when we look at df the customer ID equals 7 and employee ID greater than 20. And in this situation, that means both cases have to be true. So customer ID has to equal to 7 and employee ID has to be greater than 20. So in this case, only the last row will be picked because that's the only row that has customer ID equals 7 and also employee ID greater than 20. So for the and condition, the last row will be the only one that'll be picked. But let's look at the second situation for the or statement. And the line in the middle is an or statement in Python. And in this case, we have df bracket parentheses df dot customer ID equals 7 or df dot employee ID greater than 20. So in this case, at least just only one of the condition has to be met, then the rows will be selected. Meaning, because looking at our sample data sets, all 4 rows have customer ID equals 7, so that means we're actually going to pick all 4 rows in our data sets. So since we have covered the basics of the equal sign or the greater than a certain number, I want to cover what are other options you can have, such as exclamation point equal. What does that mean? So that means it's not equal to something. So if you have like a certain string or a certain number that you don't want to include, and that you will put in exclamation point equal or less than or greater than sign in the same box on the lower left. And the second one I'm going to talk about is the equal sign that we talked about. So making sure you have double the equal sign. I know it's probably easy to forget as a beginner, but it's a good practice to remember that it's a double equal sign instead of just a single equal sign. And then there's also an A, which is pretty much the blanks or the nulls that you will have in your data set. So you can have like functions like not an A to help you, classify if it's an A or not. That can also be helpful. But I'm gonna cover in the later slides how can you just simply drop the NAs for your scenario, and I'll cover that later. And then the next one I'm going to talk about is a greater. So I guess that's very straightforward. You can have greater or greater than or equal to. So greater than or equal to will mean that you're including the number that you're typing in. So that if, for example, if it's greater than or equal to 7, it will include 7. If it's greater than 7, it does not include 7. And then there's also less than or equal to or less than. So it's the same idea. Make sure that you know which one you're using, and also to make sure that you're thinking about if it's greater than or equal to or only. Before I jumping into how to manipulate columns, please make sure you subscribe to learn more about tech career, data, and machine learning. And if you like this video, please hit the like button, and also leave a comment below for what kind of data science project are you most interested in. Maybe I can advise you to create some new projects, and also the ideas. So in Excel, the data set's more straightforward, as like you can see all the rows and the columns that you have. In Python, the data frame it's just stored as a data frame, and it's not just gonna show you all the rows and columns, especially if your data set's really big. You're like almost impossible to see all the rows and columns. So if sometimes you just want to check, how many columns you have, you can simply do just like df.head, which will show you the first 10 rows of your data. But when you have so many columns, such as like 100 columns, the df.head would not show you all the columns available because it's just too many columns. So simply, if you just want to print all the columns available, like just showing you order ID, customer ID, employee ID, then you will run this statement of like df, which is your data frame, dot columns. So in Excel, it's very easy to delete your column. You can simply highlight the column you want to delete, and then right click, deleting the column. In Python, it's you have to write a script to do that, and I guess it's kind of straightforward, but not really. So you can do a drop state function. So then you can do df, which is your data frame, dot drop parentheses columns, and then equals to your column name with the brackets. So make sure that the first thing you need to make sure is that you have a bracket, and then also to make sure that your column name is in quotation marks, so that you will drop this specific column. So you typically will want to drop one column or a few columns because you think you did your machine learning model, and then realize that some of the features are not great for your model, and that's why you would want to drop them. But it doesn't work that well if you just want to pick like a few of your columns from your let's say like 20 columns that you have, or 20 features you have. So making sure that you have both ways of either dropping your columns or picking specific columns will be very useful in this case. And so let's say if you have this data frame orders, and you want to pick order ID, customer ID, and order date, you can. So the previous example I gave was to drop, then in this case you will drop the employee ID and the shipper ID. But imagine you have a lot more columns, like 20, and you only want to pick 3. That would be very painful to include the other 17. So then in this case, if you want to just order ID, customer ID, and order date, then you'll simply do df, double the brackets, quotation mark, order ID, comma, quotation mark, customer ID, and order date. And so the first thing you need to remember is that you have to put double quotes. Then because that's like very easy to forget, and forget to type double quote, but making sure you have double quote is very important. And then also to make sure that your columns are in quotation marks. That's also very easy to forget, but those are two things you need to remember with this function. So in feature engineering, you will want to create new features based on your existing features. And you can do that by simply, creating a new column, and you will always do this in Excel, where you just add a new column with a name, and then do some sort of function of calculating the other 2 columns. And this can be done as well in Python by creating, let's say, the open rate of your emails. And you'll do that by df bracket quotation mark open rate equals to your df dot open email. So the open email is your open email column divided by your delivery email column, which will give you the percentage of, the open rate. And this is actually very commonly used in any machine learning models, because when you try to create like a machine learning model, you always have a lot of features. And sometimes you might even find out like a lot of the features are like the open email and delivery email. They're highly correlated because you cannot open an email without delivering an email. And some of the like logistics regression model or some of the other models are not great with like highly correlated data. And so you're gonna run into a lot of problems if you include both of these features. But then when you calculate in terms to the open rate, then you're getting rid of the problem of having two highly correlated data features that you have. So this is actually very helpful in a lot of the machine learning models or projects that you'll be doing. So make sure that you remember this, that you have to do quotation mark and brackets for your newly calculated column. And then also to make sure that you remember to always call the data frame dot column name in your equation. So let's quickly cover what I have talked about today. First, we talked about filters with the end condition or condition. And also we talked about, the 5 different filters you can use for equals to, NA, not equal to, and greater than or less than. And then we also talked about, how do you show all your columns that you have? Because when you have a data frame that has like 20 or 100 columns, that when you do df.head, which shows you the first 10 rows, will not show you all the column names. So the df.columns will show you all the column names, so you can, just see all the column names without looking at the actual rows of data. And then we also talk about how to drop the columns and pick specific columns. Depends on, these two are very useful, depending on how many columns you're trying to drop or trying to pick. And then we also talked about, a little bit of like feature engineering, how you'll be able to do that by, creating new columns, based on calculation from your other existing columns. And that'll be very useful to create new features that you can put into your model.